All right, so we're on journal 36, our very last journal for this semester. And I want to just say that this journal here is just this problem or this formula that you need to write down in your journal. There's no bell work, and also this problem right here, you will notice it comes from packet 7, page 6, number 3, so you don't have to write this in your journal. I'd rather you work it out on your packet. But before I get there, I do want to explain what this formula does. So you guys have been solving polynomials, but here's the thing, I've been giving you the x, or one of the factors that help you solve it out so you can use synthetic division. But what if the case is that I don't give you an x to start off, or I don't give you a factor? So what we can do is we can just generate a possible zeros or possible solutions using this formula here. So it will make more sense when I apply it to your homework. So what we can do first is use this formula, and you'll take a look that this formula uses the constant and the leading coefficient. So using your homework as an example, I'm going to grab the constant, which is like the number at the end. So I'm going to use that as green. So this is my constant. And my leading coefficient is always the number that is in front of the highest power. So my highest power is x to the 4th. So the number in front is the 5. So this is my leading coefficient, or I'll just call it as LC for today. So what you have to do is you're going to figure out the factors of the constant and the leading coefficient. So in this case, the constant. So to set up this formula here, you have a plus and minus. It just means that the answer can be a positive and a negative. And then you have this fraction, which tells me that I have to divide the factors by the leading coefficient. So factors of 10, basically saying what numbers divide into 10. Well, you can always divide 1 into 10. So 1 is always a factor. 2 divides into 10. 5 divides into 10. And then itself always divides into itself, right? 10 always divides into 10. So you always want to start with 1 and with the number that you're given. And 2 times 5 gives you 10. So I know these are all factors. Now, factors of 5 are 1 and then 5. And I think that's it. So what we do with these numbers is we generate a list of possible solutions or possible zeros. And what that's going to look like is, well, just first take your number in the denominator and divide every number in the top by that number in the denominator. So I'm going to forget about the 5 for a moment. So 1 divided by 1 is plus and minus 1. So every time you divide, you need a plus and a minus. 2 divided by 1 is plus and minus 2. 5 divided by 1 is plus and minus 5. 10 divided by 1 is plus and minus 10. And now I'm going to so I'm done dividing by the 1. Also notice every time you divide by 1, it's just itself, right? So you could just really take the top, put a plus and minus in front of each number, and there you have the first part that's divided by 1. When you divide by 5, 1 divided by 5 is 1 over 5. I'm going to keep that as a fraction. No need to pull out the calculator. 2 divided by 5 is plus and minus 2 over 5. 5 divided by 5, well, isn't that plus or minus 1? 5 divided by 5 is 1, but I already have that on my list. So I don't need that because I don't want to create more duplicates if I already have it, right? So in this case, the next one, 10 divided by 5 is 2, but I already have plus or minus 2. So I'm not going to write that on my list. So it looks like the only numbers on my list are these that I've already generated. And so what it's saying is that according to this polynomial, these could be the possible real solutions. But it's not all of them, because we know that based off this power, the highest power is 4, so there should be 4 roots. It's just saying that up to 4 could be in this list, but we don't know what the 4 are. So right now, I just want us to practice making this list, not necessarily getting the solutions yet. We'll get there. But for now, like I said, let's just make the list first. So I'm going to do problem 1 from the packet on this page. So if you head over to the next slide here. All right, So this is problem 1 on page 6, and like I said, problems like 1 through 4 on that page 6, you're just listing out the possible rational zeros. You are not solving for it. So like in this problem here, if you need to make that list, remember it's the plus and minus, and it's the factors of your constant over the factors of your coefficient. So I'm just going to put coefficient, so leading coefficient. So I'm just going to write that as LC, just for abbreviation. So what I have here is, it looks like 30 here is our constant. So I have to find factors of 30, and our leading coefficient, which is in front of the x to the third power, is 2, so that's my leading coefficient. So I have a plus and minus. Make my fraction here. I gotta go find factors of 30. So remember, we can always start off with 1. And then 2 divides into 30. 3 divides into 30. 4 doesn't divide into 30, but 5 does. Okay, let's think about it. What multiplies with 5 to give you 30? Well, that's 6. Also, you will notice you form a rainbow, and I'll show you what I mean, but you form a rainbow when you figure out the factors. Like 5 times 6 gives you 30. 3 times 10 gives you 30. So that's another one. And then 2 times, what multiplies by 2 to give you 30? 15. And so 2 times 15 gives you 30. And then, last but not least, 30 times 1 gives you 30. And it makes a rainbow. Not that it's really relevant, but it helps you figure out like how many factors are there, because it should always pair up when you line them in order. It's a quick way to check. This is something that elementary kids do when they are first learning factors. If you didn't learn this, no worries. So factors of 2, or the leading coefficient, would just be 1 and 2. So in this case, you have to divide all the numbers by 1 first, which would just be itself. I would have, let's make a list here, plus and minus 1, plus and minus 2, 3 divided by 1, plus and minus 3, 5 divided by 1, plus and minus 5, 6 divided by 1, plus and minus 6, 10 divided by 1, plus and minus 10, 15 divided by 1, plus and minus 15, 30 divided by 1, plus and minus 30. After that, I need to divide by 2. So everything on the top gets divided by 2, but remember, duplicates, don't add it to your list. So 1 divided by 2 is plus and minus 1/2. 2 divided by 2 gives me a 1, and I already have that. 3 divided by 2 is plus and minus 3/2, which is not on my list. 5 divided by 2 is also not on my list. 6 divided by 2 is 3, which is already on here. 10 divided by 2 is 5, which is already on here. 15 divided by 2 is, well, 15/2. It can't be reduced, so I'll add that to my list. 30 divided by 2 is 15, which is already on my list. So it looks like my list of possible real zeros is this long one here. So hopefully you can see that this is not very difficult, but maybe a little bit tedious because you have to write all the factors and then divide it out. All right, so now that we've gotten kind of the hang of finding the possible rational zeros, I'm going to show you next why they're useful with problem number 5 on this page. All right, so in this problem here, I have an equation and I have to find the zeros this time, or basically solve for x. Now, I always like to start off the problem by figuring out, how many zeros am I finding for? How many roots am I finding for? And in this case, the degree of the function is 3. That tells me my highest power is 3, which tells me how many roots I should get, which is 3 roots. So that gives me an idea of like how many solutions should I have in the end. But here's the problem. In general, or these past few days, we've been using synthetic division to solve and find all the x's. The unfortunate part is like I give you the polynomial, but I don't give you any of the roots or the x values or the factors to start off with. So what do? You can't make your box because you don't know what number goes in the box, right? So you can't use synthetic. So instead, what we have to do, you're going to have to just trust me for the first few steps and then you'll realize why. But you're going to have to first figure out the possible roots they could be or the possible zeros they could be, okay? Because this helps us narrow down our search. So to figure out the possible roots, we just learned that you need a plus and minus, and you need the factors of the constant. So here's my constant. By the way, if this constant has a negative number in front, like this one does, you don't have to account it. The reason why is because when you find factors of this guy, remember, there's a plus and a minus sign in front of it. It will be, accounted for. That negative sign will be accounted for using this formula. So that's the constant. And our leading coefficient is 1. So, factors of 1 is just 1. Factors of 12, which goes on the top, is 1, 2, 3 works, 4 divides into 12, 6 divides into 12, and 12 divides into 12. And I think that's all of them. Yeah, 3, 4, 2, 6, 1, 12. So we can see that we're dividing by 1. So that means if I divide everything by 1, it's basically the same list that's on the top. So we would have plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, and plus and minus 12. So all I did was divide each number by 1 until I got done with my list and made sure I had a plus and minus in front of every number. So what it's saying is that perhaps these 3 roots could be inside this list. We don't know, okay? The only way to check is to look at the graph. So we're going to check the graph, and I'm going to personally use Desmos here to show you what the graph looks like. I really recommend using Desmos at home since it's a very easy app to use or very easy website to use. So I just want to give you a fair warning. When you type this into Desmos, make sure you say like this is y equals all of this. Remember, f of x just mean y. Or you could, honestly, you could probably type in f of x equals that and that'll still graph it. But I thought I mentioned that. So what I'm going to do is I'm going to grab, let's see if I can flip my camera here. So I'm going to do video, switch my camera. And here we go. So I'm going to type this into my keyboard. And so I'm already in Desmos, as you can see, and I'm going to type this in. So I'm going to do y equals. Maybe I can get you close to the screen. And then I'm going to do x to the 3rd power because that's the, the equation. So x, and I need the power, so I'm going to do shift, and this is 6. And that gives me that exponent, so I'm going to put in 3. And then I'm going to use my arrow keys to come down. And so this says plus. I'm going to put plus, no, that's not a plus, shift, and that's 2x, shift 6, give me an exponent, 2, thumb down, minus 11, x, minus 12, aha, there we go. So here's my graph. Let me scoot this over. And you can zoom in and out too. So I'm going to zoom out just to see what this really looks like. But there it is. It kind of looks like a squiggle. But what I want to know is like the roots, right? I can see 1, 2, 3 roots, and I'm going to zoom it back in so I can figure out, where did it hit on the x-axis. So it looked like it hit at -4. That's like -1 because it's between -2 and 0. So -4, -1, and right there it's past 2. So I think that's 3. So I'm going to redraw this on my, my screen here. So I'm going to pause it right there, throw this to the side, we'll use it later. So it looked like to me I had this graph where it hit it at -4, -1, and +3. So I'm just going to mark it there. So those are my possible roots. And then it looked like it was curving down, then back up. So here's what we need to do. We need to verify that this graph has the correct and valid roots. The only way to do that is to use your list, because if you were to use this graph, just the graph alone, you couldn't really prove 100% that -4 is the true answer because you're making an estimation, right? You're using your eyes to tell me what the answer is when, what if you're off? Like, what if that x-intercept is actually at 3.99? Like, how could you tell with your eyes, right? So the only way to double check is to use this list to make sure that that number is available. So what I'm saying is, like, if I were to list off all my x values that are true, so -4, ask yourself, is it on your possible list of zeros? And yes, it is. Look, -4 is accounted for, right? So in this case, I can verify that -4 is one of the roots. Yay. And now we can go to the next number, -1. Is it on our list? Yes, it is. Behold, there it is. So -1 is approved. 3, let's check if it's on our list. And it is. So +3 has been approved. And lucky for us, that's 1, 2, 3. That's 3 roots, which is all we need. So all of these roots are real, and we have them all now. That means we don't need to use synthetic division because we found them all using the list and our graph. And that's it. In the next problem, we are going to see that, we don't find them all in the graph, so then we have to use synthetic division. But I just want to say, like, the overall arching idea of this lesson is that I want you to use this formula to find the possible zeros so that you can narrow down your search. Because if you didn't have this formula, what you would have to do is use all the numbers that you can think of and just keep using synthetic division until, it worked. And that would be awful. Where this kind of narrows down your search by using this list and then looking at the graph, which is a lot more helpful. Okay, it guarantees your chance that you're getting the correct answer. All right, so let's try out number 10 together. So this one's number 10, and like I said before, you're going to be solving it out and finding all the zeros. So always just double check, like, how many roots are you going to find? So the degree of the function, or the highest power here, is 4. So I know that I should be looking for 4 roots. So in this case, I know that I should be getting 4 answers. So I'm going to first start by making a list of possible solutions, or possible zeros, by using my formula, the factors of the constant over the factors of the leading coefficient. So in this case, 1. So the only factors of 1 is just 1, so that's my 1 in the bottom. Factors of 6 are 1, 2, 3, and 6, right? These numbers all divide into 6, and that's it. So if I'm dividing by 1 into each of these numbers, basically I'm just going to have a plus and minus in front of every number that's in my numerator. So I just divided all these numbers by 1 and put a plus and minus in front. After that, I know that it could be one of these answers in here if I check the graph. So I need to check the graph to double check if one of these values are on the graph, or 2, or 3, or 4. So I won't know until I see the graph. So I'm going to type this into Desmos and see if I find anything. So I'm going to grab my camera here. No, that's not it. There we go. All right, so again, I'm just going to type this into Desmos. So I'm going to open this up. So this time, what is this equation? X to the 4th. So this is going to be now to the 4th power. Oops, sorry, that's not supposed to be there. 4th power minus x to the 3rd. Oops. Minus 5x squared minus nx minus 6. All right, so let's take a look at this graph here. I'm just going to double check whether that looks the same as my equation. Yeah, I typed it in well. So here it is, and I'm going to just zoom out just a little bit so you can see, but it looks kind of like a weird W, right? And I can see here there are 2 roots here and here. So I'm going to zoom back in to figure out what are those roots. And it looks like it's at -2 and +3. So Desmos is wonderful for graphing because you can find those x-intercepts pretty clearly if you zoom in and zoom out, because the zooming feature is so nice. All right, so I'm going to pause right there and do a quick sketch on my graph. By the way, I just want to give you a fair warning. These problems take up a lot of room. So I would grab yourself an extra sheet of paper and do these on like a separate sheet if you run out of room. And then you can always staple onto your worksheet and then turn that, both the scrap sheet with your packet. Make sure you show work. So in this case, it's hit it at -2 and +3, and then it was like this weird W shape, right? So, close enough. All right, so what we're going to do here is looking at our list, we need to confirm is -2 and 3 on our list, and it is. -2 and +3 are both on our list. So that means that I've narrowed down 2 roots. So I found 2 real roots. That means there are 4 total. So that means the other 2 are imaginary. So I found 2 of them. I got to find the other 2 to make 4. So to do that, now that I have some x values to work with, right, I can use synthetic division to break down this polynomial to find the others. So in this case, I'm just going to rewrite the function here so that way I don't have to keep scrolling. So here's my equation, and I want to use synthetic division. So I'm going to use one of the x's. I think I'm going to use -2. It doesn't really matter. So I'll use -2. Remember, when you have the x value, you don't need to switch the sign. You only switch the sign when it's the factor, right? Because you have to set it equal to 0 and solve for x. But if you already have x solved, you don't need to switch the sign. So starting my synthetic division, I'm going to make my outline. So it's x to the 4th, x to the 3rd, x squared, x, and then my constant, and then I'm going to put the number underneath. So that's 1, -1, -5, -1, -6. Let me shrink this just a little bit. So remember, the first number, we always pull it down when we're doing synthetic division. So that's 1. Then we take this number and multiply it by the number in the box. So 1 times -2 is -2. Then we always take the rows and we add them. So that makes -3. -3 times -2 gives me +6. -5 plus 6 gives me a 1. 1 times -2 is -2. If you add these two, you get -3. -3 times -2 is +6. If you add these two, you get 0. And so, lucky for us, we got a remainder of 0, which is nice. But recall that this -2 here has already been confirmed that it is a true x value, right? We checked it with using the possible zeros, and it's on the list. We checked it with the graph, so this has been double checked. So this only triple checked it for you. So we don't need to know that x equals -2 because we already knew that before we did synthetic division. What we do need is basically this equation, that what you get after you divide. So you have a constant x, x squared, x cubed. So it looks like you have, 1 x cubed, so x cubed minus 3x squared plus 1x minus 3. And so here's my equation that I gathered from you after using synthetic division. And I want to solve this. So I need to set this equal to 0 to solve. And then in this case, this is 4 terms and it's x cubed. So I want to factor by grouping to solve. So I'm going to put 2 terms in each parentheses and factor out as much as I can. So the lowest power that I can factor out is x squared. So that's the most common thing they have. And so I leave behind an x and a -3. Because if I take out 2 x's from here, an x squared, I'm left behind 1x. If I take away this x squared, I'm left behind a -3. So that's why these two had to stay behind. In this next factor here, there's an x and a -3. They don't have much in common, so I can't take anything out. But here's the thing I want you to remember. There's always a 1 in front of a parentheses, right? There's always a 1 in front of any type of like term. We can say that. And so in that case, when you decide to factor out your x minus 3, since both terms have it, you're going to leave behind 2 terms. So x minus 3 comes out. you still have an x squared and a plus 1 left behind. And now we've put everything into factor form, so now we just have to set our factors equal to 0. And you will notice the first one's pretty easy. If you just add 3 to both sides, you'll realize x equals positive 3. But hang on, I already knew that x equals positive 3. So I don't need this answer because I already knew that was one of the answer. What I really need to solve is this one here. Notice how this is x squared plus 1. So if I were to solve this, it would be minus 1, cancel. X squared equals negative 1. So to get rid of a square, I have to take the square root of it. So that cancels. So x is equal to the square root of negative 1, which is, well, if you have a negative, you have an I. Square root of 1 is 1. Square root of any number has a plus and minus. And so here's the deal. You need 4 roots. Let's count up all the unique roots that you found. So it looks like x equals negative 2 and 3. That comes from the graph. And then x equals positive 1i and also negative 1i. And that is all 4 of the roots. Okay, so this does take a lengthy process, but first always start off with figuring out your possible roots. Check the graph, because if you happen to find all of the solutions in your graph, then you're done and you don't have to use synthetic. But if you don't have all of them, then you're going to use the x values that you have and try to use that towards your polynomial and use synthetic division with it. And then that way that'll lead to you to the rest of the roots that you're missing. So hopefully that helps you out and gives you kind of an idea of what you'll be doing for this homework. So that's it for this video.